Recording in
Either in a
progress.
way, this called in a grammatic way, grammar way, okay, in such a way so that the sentence makes some sense. Okay. For example, if I use one word here, let's say Vimal. If I use one more word here, let's say football. So Vimal is a different word. Football is a different word altogether. Okay. But these two words does not have any relation, right? Vimal is a different word, football has different word. But in our sentences, when we speak, we don't use a word, we instead use sentence. Okay, sentence can be Vimal can hit football. Just by adding some more word of the English, it become a sentence. So the sentence has, let's say, 4 word here. And then now after uh, connecting this word and all this word in a way that so that sentence makes some sense. Okay, but you had in a way that makes some sense. For example, hit can football Vimal, even the same word, right? But arranging in this way does not make sense. Hit can football Vimal, right? This arrangement of the word does not create any proper sentence, does not create any useful meaning. They're not grammatically right. But this is grammatically right, maybe. Okay, and from the sentence is very clear. It's very clear that Vimal is the one who can hit one thing that's called football. And those who know English as a grammar, maybe in this case this is called subject, or this is called object. This is called verb or action. All right. So the point is, particular word converting into stemming or lemma, we can do it. And why we want to convert a word into a lemma? Because we want to decrease the feature. Last time I was talking about the feature engineering. Because the machine learning, if you want to create the machine learning model, you have to use a number. Every number comes from the word. But if a lot of words, then a lot of number, a lot of features gonna come up. That's what we'll discuss in upcoming classes when we go more advanced in the NLP. Okay. But lemma and stemming is a way through which we can reduce the features or feature extraction we can do. Where one particular word will pick and try to convert into the root word or the stem word or the origin word. Okay. But that is what required when we do something in the future classes, right? But just by knowing the word does not give much information about it. For example, let me take one more example. If I give a word read, okay, just by looking at this word, one single word, it is kind of impossible. It is kind of impossible to understand, okay, the grammar of this word. Okay. So what is the grammar of this word? If I ask you, what is read? Okay. Is a verb, is a noun, is an object, is a present tense, is a future tense, is a past tense, right? So if I ask you guys, my discussion to you, everyone, right? You can put all in the chat box also. Okay. If I just give the word read, it's a very simple English word, right? Okay. Only read does not make much sense because normally we human beings speak the natural language, less English. Okay, we have to use this word in a sentence. Then sentence give you some information, right? And with the information, we can talk, we can chat. Okay, we can give the instructions. And that's what the plan is. So we have to talk to our machine. We have to give the instruction to a machine in a natural language. But they should understand our natural language, called NLU. Okay. But how they understand? They don't understand. We don't want to give them only the word. We have to give the entire sentences. Like we talk and we speak, we write. Okay. But the challenge is right now we're using English as a language. Okay. And in the English language, it is kind of complex language where there will be a lot of exceptions, a lot of complexity. One word, okay, like let's say read here, will have a different meaning depend upon where you place this word in your English sentence. Okay, just by giving, just by giving, okay, uh, only the word, nobody can actually determine, especially in the language called English. Okay, what is the right meaning of the word read? Yeah, if you talk Hindi, Hindi does not have so much complexity. Learning of English, Hindi may be different, may be complex, but by looking at the word, okay, word of Hindi, we can very easily determine what we're talking about. For example, in Hindi, for example, karta hai, karti hai. Okay, so we know if I use karta hai, if you know Hindi, for example. So we know we're talking about the gender, male, karti hai. So that means we're talking about gender called female. Okay, but in English, for both the female and male, we use a one single word. Okay, in most of the cases. So by looking at the word, very harder to understand, right? That's what I'm talking about, the complex. Yeah. Similarly, one example was read, for example. If I ask you, what is the meaning of the read? Okay, we know the meaning of the read, but what we're talking about, we're talking about the object, we're talking about the verb, we're talking about present tense, past tense is very harder by looking at the word. Why? Let me give an example. For example, if I write this statement where I'm going to use the word read, for example, I read books. I read books on quantum computing. This is one of the sentence of English, right? If I talk about this sentence, by looking at the sentence is now very clear. The read, the way you place the read, okay, this is a present tense. Okay, it's a present tense. Okay, or maybe I can say simple present tense, maybe I believe. So it's simple present tense. Okay, that means if I talk about convert Hindi, so that means मैं quantum computing की book read करता हूँ. Like it's a normal thing I always do. But if I use one more sentence, almost same sentence, just if I write I read a book on quantum computing. If you see here, this is almost exactly the same sentence. See here, exactly the same sentence. If you try to compare also, on quantum, I read. Only slight difference is there. Instead of here I use S, I don't use S here. I don't use A here, I use A here. Very small slight change. And just because of slight change, the entire meaning of read has changed, even though pronouns has also been changed. So first we use to say, first line we say I read books on quantum computing. And second line, if you try to pronounce this, it's known as I read a book on quantum computing. This is how we pronounce it. The spelling is right, the spelling is the same, but pronunciation also change. Okay, but yeah, computer does not have to understand with the pronunciation, because you have to write this thing in the RAM and hardware or hard disk. But here we see same word, right? When the same word here, okay, it is known as past tense. Completely the grammar change, right? It's like this line means मैंने quantum computer की book पढ़ी थी. A big difference, right? So the point here is what I'm trying to tell you here. Okay, we have to teach our machine our natural language English, and English has lots of exceptions, lot of complexity. Learning particular word does not make any sense. Finding the lemma or the stemming, find out the root word will help you in machine learning training to decrease the feature that we're going to use a lot. But finally, it become one word, right? Okay, finally, by one word. But technically, what we have to teach to the machine, we have to teach the machine a natural language. There's go sentences, there's go grammar. And learning the grammar is not so simple in English, right? Why is it? Single, actually, it's very simple, present, past, future, all the tenses and other things. Okay. Only challenge is the arrangement of the words. Okay. How the word has arranged, that will change the entire meaning of the word for that particular sentence. See, in the same example we see here, same word placing in such a way, the entire meaning of the sentence has been changed. So one become present, right? Simple present that you normally do per day basis or per normal day, your day-to-day life routine. The last sentence like a past, you've done once, right? In the past, maybe. Okay. So that is the reason teaching or training the machine, creating the AI with the English language is not so much simple. And this example, guys, is known as linguistic feature. Linguistic feature. Okay, where same word in a different order can meaning something completely different, right? Okay, so what linguistic feature or the linguistic analysis is, okay, by looking at the sentences, we can analyze what is the meaning of that particular word in this particular sentence. Or I can also use one more time here is, by looking at the sentence, we can come to know, okay, the right meaning of the word in the sentence. Okay, by looking at the sentence or by looking at the, I can use one word term called here is called the context. So if you see in this sentence or in this context, okay, this word, because I use books as, become the simple. Here this word, because I use book with a, no, as, this is how we in this grammar, then in this context, this has a past tense. So by analyzing, okay, by looking only at the read, it does not give any information. By looking at the read with the nearby words, the word that is around the read would give the entire context about the read. What the read is all about. The present tense, past tense, singular, plural, and many more other things also. That is called linguistic analysis or the linguistic feature. Okay, because okay, without knowing the linguistic knowledge, you can't find the exact information. And without knowing the actual information, you can't take the decision. Neither we can take as a human being a decision, because without understanding the word or the, I can say, the sentences. Similarly, machine also not able to understand it, what you're talking about. Okay, and if a machine does not able to understand what you're talking about, how they can do something what you want to do by the machines. Okay, so one of the main topic, guys, for today is we are going to learn linguistic analysis. Okay, also known as linguistic feature. That's what the topic we are going to learn. Okay, and here one of the main library of Python who are great in understanding the linguistic feature is called Spacy. So Spacy is a Python library that I used in my last class also. If you remember some of the example I show you with Spacy, I think lemma and something we have seen in my last class. Okay, but the one of the great thing about the Spacy is very much trained to understand the linguistic feature or the linguistic analysis. But before you understand the linguistic feature or linguistic analysis, you should know one thing. Okay. So main topic is linguistic. This one. Linguistic. G. Analysis. Or analysis. So before you understand the linguistic analysis or the feature, okay, you should know what is POS, part of a speech. Why? Because every sentence of English, okay, you can create any sentence, they always have part of speech. Without part of speech, none of the sentence can be formed. Okay, even though every word in a sentence has one and other part of speech. Okay, similarly, for example, if you talk about any example, okay, if you talk about an example, like I read a book on NLP. Okay, so here also every word has one and other part of speech. Okay, without part of speech, thing won't be complete. For example, let me take one other example. For example, if I write the word the cat chased the mouse. Okay, this is a grammatically correct sentence or speech, I can say. But every part of the speech or POS, okay, has one another type of POS. Okay, for example, cat is a noun. Mouse is also noun. Okay, but it is a subject. It is an object. Chase is a verb. Okay. Similarly, the maybe have something maybe maybe a kind of determination or maybe some whatever you say, determination and other things. Okay, so everything here has some another part of speech. Okay, so if you see here, I open some document here. There are a lot of different part of speeches you have. Okay, you have maybe verb or noun or pronoun or determiners, adjective, adverb, preposition, conjunctions. So there are probably 8. Sometimes somebody write here 9, but mostly the 8 is a typical part of speeches available in your sentences. Okay. For example, here the chased is verb, action, right? Cat and mouse is noun. Okay, but by chance the cat is the subjective noun or subject, I can say, or mouse is a object. Okay, but whenever you write the somewhere, the cat, the mouse, it becomes the determiner. If you talk about something about good, right, then it becomes the adjective, right? So those things you might know. Otherwise, this is not the English classes to understand. But the point is, every sentence, every word has some part of speech. Either they are preposition, conjunction, or, while, but, by, with, all the stuff. Okay, or maybe noun, pronoun, or adjective, verb, and adjective, right? None of the sentence English is is without POS. And every word of the sentence has some of the other POS. So the 8 POS is there. By this document is written 9, but typically we have 8 part of speeches we have. Okay. So I'm talking about POS here is because if you want to teach a machine about your language or they understand your natural language, right? Only giving the word does not make any sense. Okay. First, they have to understand in this word where you're applying this word on the sentence. And with respect to and with context to that sentence, okay, part of speech determine, okay, determine the what is the right, by looking at the person they determine what is the right meaning of that particular word here. Just for example here, in this particular example, if you talk about read, read is a verb. This read is also a verb like action. So if you just talk about only part of a speech, so part of speech, a general way, they will say, hey, both the read are verb action. But if you go more deep into part of speech, this called fine grained level. Okay. Just by talking about part of speech, they say both are verb. VRB, verb. But if you try to go more deep into this topic, part of speech, this is called fine grained level. Okay, that concept is called POS tagging concept. So if you go to more deep level, fine grained level, this is called tag concept or POS tag concept, part of speech tagging. And then if I ask again, what is the read? They say read is a verb, but is simple present tense verb. This read is a verb, but it's a past tense verb. Okay, so that's that level of that level of thing you can also determine. Why? How? With the help of concept called tagging concept. This is also known as part of speech tagging. So part of speech tagging has this capability. Okay, so this typically known as fine grained tagging. So they have a capability. Normal tagging, so I can say this better word would be POS tag. Only POS tagging is they will tell you I'm verb. But if you go to more deep level, they go fine grained level POS tagging. They will talk about is a noun, past tense, present tense, superlative, adjective, a lot of things there in English, they will talk about it. Okay, they'll talk about it. So let me give very quick demo of this particular example to give you quick information. And then we go more deep into this topic. Okay. So let me go to our code. Sorry. Give it a notebook. What exactly we are going to do, guys, here is if you want to teach, again, same thing I repeat, if you want to teach your machine about natural languages, so you have to teach the machine the way we have trained on the English, right? So we started with the characters, then we go to the words, then we go to grammar, then POS, part of speech, and different form of grammar. Okay, so similarly, you teach this guy. Then only I can say my machine will become AI enabled for the NLP use cases. Okay, and especially for the part of speech, and especially for the tagging, and especially for the linguistic analysis. So one of the Python library that is available, this highly mature to give you a proper linguistic analysis. They give you proper POS tagging, or they give you proper POS fine-grained level of tagging also. Okay, because without knowing the proper meaning of that word, because as the person changes, the meaning of the word changes, called linguistic analysis. You can't determine what somebody's talking about. Similarly, this without this, how machine can define what somebody's talking about. So let me import the specie. And guys, if you remember in the last class, we have downloaded one of the specie library. So let me load that library. Okay. So in the last class, I have downloaded the English library. Okay. English library is called Code English Web, I believe. Or is, I think, small library we have downloaded. So let me load this. Okay, and store in one variable, let's say NLP variable. It's just a variable name. So NLP is a variable, or you can think is like a object. Okay, and with this object, we can do multiple thing on your sentences. Okay, for example, I can tell my NLP this variable, just as a variable name. I can tell my this variable that, hey, I'm going to give you one English sentence. Okay, you have to do the complete lexical. I'm sorry, I'm saying word lexical. You have to do complete linguistic analysis. Okay, and sentence is let's say this one. I read books on quantum computing. And let's say dot. So this NLP is a variable, is a any variable, right? Come from specie from this dictionary. So this dictionary is going to perform some operation in this statement and give you a complete linguistic knowledge. Okay, or give you a completely linguistic feature. Okay, so let me store this into a variable called document variable. It created an entire document for the linguistic. Okay, one thing they do by default for you, they know this is a different word, this is a different word, different word, different word. QC different word, and dot is a different word. So one thing what this library will do, NLP keyword or NLP variable will do for you. Let me give the different variable name my NLP so it won't be confused, right? It's just a variable name. Okay. It's what one thing what they do for you is they convert every word as an individual token. Okay, so if I try to print dog, they say it look like same string, but it was the string, but it's not a string, it's an individual token. And this token, okay, has the person number 0. Next token, format. Next token has a, let's say, person number 2, books. Person number 1, read. So they know everything is token. Let's say token number 5 is dot. Token number 4 is QC. So they know everything is a token, individual word. Okay. And here they also print as a normal token, but if you want to print as a normal string also, you can use a text keyword. Then they print as a strings here. Let they print as a string. It's not print as a string, right? It's because this is a token. Token means that has a they know about it more. They know this read is present tense or past tense. Okay. They know this is a verb. What is token? Token means from the statement, if you try to do a linguistic analysis, it means we know every word individually here, what that meaning of that word in that particular sentence. That makes every word individual token. So read is a token. But if you want to get the string out of this token, then text is a keyword you can apply. So here I can add text, it give you normal string, the normal Python string. Or because read is a token. Okay, so here again, let's say read is token. Now you can ask what this token is all about. Can you tell me the part of speech of this token? So here, when I run POS, they'll tell me the part of speech. And here they print the number called 100. So what I mean by 100 here? 100 is one unique internal ID they give to this token. So Spatie has given some internal part of speech ID. So every possible word, okay, in the English dictionary, they give one unique ID for the internal references. For us, it's very harder to understand what the 100 is. But every word depend upon where they're using. For example, read, here they use read. We know this is a present tense or simple or singular present tense. Okay, so that is driven by the number 100. Right? It is for the specific internal use case, internal calculation. For us, 100 does not make much sense. So if you want to know what exactly this part of speech, you can use pause underscore. That will print something useful to us. Now they say, hey, I know in this particular sentence, read is a verb. Read is a verb. So here they will talk about the part of speech, simple part of speech. But if you want to go more deep into the part of speech, let's go fine grained level, let's go tagging actually. Then we can also find the tagging of this guy. How to find the tagging? I can say, do one thing, tell me tagging of this guy. Tag is a keyword. Okay. Again, every tagging, they give you some internal number, internal hard-coded number. Okay. So this number Spatie used to search in the entire dictionary. Which dictionary? This dictionary. The meaning of the read in this dictionary. Okay, but this number does not make so much sense to us. So instead I can write tag underscore. Then we convert this number into a R readable way so they understand what they're talking about. Okay, here they write WBP. Oh, sorry, VBP. Okay, and here VBP means it is a verb of singular present tense. How I know this? Obviously, I don't know. But for this is the again word or some kind of constant given in the Spatie library to tell VBP is a fine control level of tagging of part of speech. That meaning of VBP is a singular present tense. So how I know? Just search maybe in the Google. Okay, Spatie NLP VPP. You can find somewhere. So in some of the document they will present. Okay, the meaning of VBP is a lot of like words they given to you. Somewhere in the document you can find the meaning of VBP. Here in the Spatie means, so you can find somewhere to find the document proper, right? It's called singular present tense. So technically I already opened one document for you. Okay, this is a document they have. So in this document you can go more deep. You can somewhere you can find there's a keyword called VPP. That means you can find somewhere. Okay, that means maybe here VBPV, right? The singular present tense. Otherwise, you don't have to search in Google. Also, there's a one function available in a Spatie. That's called explain function. Okay, in this function you can pass this keyword VBP. They'll explain about this keyword. What is the meaning of this VBP? So VBP is a keyword that means is a verb. Okay, and it is a singular present tense or simple present tense. Okay, so VP is an intelligent word they given to you, but the English meaning in the grammar way is singular present tense. That's what that is my right. The point is, in this statement, the way we have placed the read, okay, your specie has a capability to make our program AI enabled for the for the um, uh, uh, linguistic feature or linguistic analysis. They know, according to the placing of this word, I know this is a present tense. That's what they print here. But if I change this statement, let me create one more example for this. Just by changing this statement, right? I read a book on quantum computing. Let's say this document 1, 2. Now this NLP, this one, has a capability to do very quickly the linguistic analysis. And here, if I talk about the doc number, this one, and doc, if I just go and find the personal one, or read, and here, if I ask, what is your POS? Verb. Okay. What is your tag? See here, same word they're talking about here, tag called VBD. Same word here, they're talking about VPP, difference here. And VPP means is a singular present tense verb. And VBD is, I don't know, this is some inter keyword of the specie. So we can ask the explain function, they've explained to us what is the meaning of this line. So can you explain what is VBD? So they talk about the VBD is a verb of past tense. Yeah, so beautiful it is. It means that's what the English is complex, right? Same word, okay, where you place, according to place, the entire meaning, entire context of this word has been changed. Okay, but who determined the context of this word for their preposition? It determined by the linguistic analysis. So this is one who will analyze, okay, the context of this word. Okay, so it's a very beautiful example, right? So here says present tense is a past tense. Because if we know English language, we know what they're talking about, the present and past. But now machine also now know, with the help of specie, with specie library of the Python, okay, and say I know the POS of it, part of speech. I also know the fine grained part of this, part of speech. Okay, so I can also give one more word here is simple part of a speech is also known as coarse grained part of speech. Like they only talk about verb, noun, adjective, adverb, preposition, like 8 different POS they talk about. But if you go more deep into POS, then it's known as fine grained POS or fine grained tagging. Sometimes also use the word tagging. Okay. So it can be verb present tense, verb past tense, determiners, many more, superlative, comparative, right? A lot of things what you might know in English. They also know, who know, especially know whether this from this library. Okay, so that's a good thing we have. Okay, now interesting point is in this example. Okay, interesting point is how they determined the context of this word. Okay. What I mean by this, how they determine this read in the first line is simple present. And next read in the next line is a past tense. How they determine it. Okay. They determine the way we determined. For example, how we determined. Okay. This read is simple present. Because we teach in our school days that after the verb, if you have a noun with s, okay, then this become a present tense, simple present tense. Again, if you have verb, then again a come up, then kind of book without s, all this sort of stuff, then it become the past tense. Some kind of rule has been given to us, right? Okay, that rule, okay, the way it has been taught to us, these rules, is by giving you grammar, right? And the way they teach you the grammar is known as syntactic analysis. Okay. how they differ. For example, okay, how they teach to us, it is something like this. For example, I take the same one more example. The cat chased the mouse. So these are pure English language, natural language. Okay. By looking at this natural language, okay, if you notice, guys, in this language, this is a noun, this is a noun. Okay. How I know? Let's write in the code very quickly. Let's go and find. So let's have document number 3. My NLP is just a variable from the dictionary, and let me write the cat chased the mouse. Okay. We can add the dot here. Okay. And now if I talk about doc 3, okay, and if I ask what is there in the second person, 0, 1, this from 0, cat, and let me ask, can you tell me the POS of this? They say is noun. Okay. Or can you tell me the tag of fine-grained POS? Is NN. So you can just search about NN. What is NN? It's a noun. But if you just try to ask them what is the meaning of NN, it's a singular noun. That's what the singular noun is, right? The cat. But similarly in this doc, okay, if I ask 0, 1, 2, 3, 4 is a mouse. So can you tell me what a mouse POS is? Again, it's noun, right? Because it's noun, right? And because mouse is noun. But you can tell me tag of it. Again, it's NN means again the singular noun. That's right. Okay. But if you notice here, in one sentence, there's also noun, there's also nouns. The main part of the sentence is 100% right. Okay. But in this sentence, okay, chased is the one. Okay, that is verb. Very quickly, let me check. Okay, in this document, the chase is the second 0, 1 third person. And if you ask what is chase, let me take the POS is a verb, or maybe as a tag is a VBD. VBD, you know, it is a past tense. You chase, right? They know it's a past verb. Something chased happened in the past. Okay, but here the beautiful thing about the Spatie library is what we're using right now is they know in this sentence all the part of speech. This is also part of speech, part of speech, part of speech, part of speech, and part of speech. All the part of speech has a relationship to each other. Okay. And understanding the relationship is the one of the most important part. So understanding the relationship of the statement is known as syntactic analysis. Okay. And how they determine the relationship? By understanding the dependency between the words. Okay. So they know this word and this word is dependent to each other. And who make them independent? Chased. If chased is not there in between, this two word has no dependency. So cat has somehow depend on mouse, or mouse somehow depend on cat. Okay, depend on the cat. But who make them dependent? Who connect them? Who create this dependency? Or who create this relationship between these two words? Chased. Okay, so I can write in this way: chase is the one, the main root who make cat and depend to each other. So you can say cat is related to chase, and mouse also somehow related to chased. And because the chased, cat and mouse are dependent to each other. They have some relationship, right? If you write different word, for example, cat is animal, mouse is small animal, just two different sentences, they have no relation, right? Two independent sentences. But in this sentence, cat and mouse, maybe noun, but they are dependent to each other. And who make them dependent? Chased. As a verb, who make them dependent. Even though the is also the is a kind of part of speech, but this the okay is depend on the cat, right? Cat give the meaning to the, or the meaning the cat to the cat. So this the is been relationship with the cat, or this the small the has been relationship with this mouse. My point here is this is how we see the English sentence. But if you talk about the SPECI or the NLP, okay, in the NLP, the sentence has been understood by this kind of way, the way I draw here. And if you try to see, this is more like a tree. So in the NLP, your sentence has converted internally in a tree format, where we have some root who connect everything. Then we have some child, then they have their child, or that's called leaf also. Okay, and with the help of this tree, we can very easily understand the cat has been depend on cheese, mouse and depend on cheese, the depend on cat, the depend on mouse. Okay, that is the reason this is known as dependency tree. This is known as dependency tree. Okay, so in this dependency tree, okay, help you understand the linguistic analysis. By this tree, now we know very, very easily cat is also noun, mouse also noun, but cat come in this left side, mouse come in the right side of the tree. You know, if you know a little bit about the tree or tree data structure, what will come in the left of the tree is called left child. What will come in the right is called right child. So if anyone come on the left side, is known as subject. Anyone come the right side, if it is a noun, then it becomes the object. Okay. So normal SPECI will find POS. And so I find both the POS is noun. Who carried this noun? So dependency tree will figure out, okay, Che is the one who carried the noun, who carried both the nouns. Okay. And because Che is the one who carried both the noun, by chance Che is the verb, does not matter, but Che is the one who carried both the nouns. So who come in the left? Cat. Who come first? Come in the left. And who come the left? It means we have some inter rule. Anyone who there in the left is subject. And who comes the right is object. Okay. It's object. So my point here is I'm just giving some example. Okay. Example here. Okay. To tell this dependency tree will give you the relationship. The change relation, this one, this cat is relation with the. Okay, and guys, if you search in the POS, any noun that is started with the, that word become the determiner. Cat is a noun, but the is the determiner. For example, if you see maybe this document, determiner. Anything placed in the front of noun that explains the quality of the noun. Example, my, many, my pen. Okay, my daughter, my son, the guru, for example. Okay, so in the front of the noun, if you put any of this word, that will change, express the quality. Okay, or introduce the noun maybe. Not determine this. Here in the front of a cat is a noun. If you put something like the, for example, then the become the one of the POS, like a noun, pronoun. Okay, it is non-determiner. So it is mouse and noun. Anything they put on the top of the noun, again it is become the determiner, also known as DET. Determine. So if you ask, okay, in this document, okay, what is the 0 position? D. So can you tell me about the POS or the DET, determiner? Okay, or can you tell me about the tag of fine-grained DT? And if I understand what is DT is, so you can explain. Can explain what is DT, the space internal keyword DT. Is a determiner. Okay, and what determiner is an English concept, right? It's not a space or NLP concept, it's a pure English concept. In English language, DT means determiner means this word, what I explained to you in the English grammar. Okay. The point is, if you understand here is, if you place the somewhere else, the might not be the determiner. That might be maybe conjunction or preposition, I don't know. Okay. Placing the word somewhere here and there, they will change the meaning, the way I given the example of read. Okay. This is called linguistic analysis. But how linguistic analysis come to know, okay, this read is simple tense or present tense or the past tense. So linguistic analysis behind the scene, to understand the linguistic analysis means the right meaning or right context of this word, they create synthetic dependency tree by doing synthetic. Okay, not semantic. Semantic is different thing, guys. By creating syntactic dependency graph to understand relationship, right? First, they try to they try to find the connecting verb, main thing who connect the things. Okay, for example, if I if I remove cheese, this standard has no meaning. So any word The main word of your statement is always not a root word. Mostly it's verb, not always. Okay, but yeah, if you if you remove the from here, it does not remove the sentence or does not make the sentence obsolete or has no meaning, even though sentence has a meaning. So the is not the root. Okay, but che is the one thing who connect the things. Any word that connect and make the entire sentence, that word is always root. So we start forming the tree. That's called dependency tree. Dependency tree, and then okay, with respect to this word, we start finding the relationship. What relation the cat with this word? What relation the mouse with this word? And we are forming this tree. Okay, so anyone who know DSA, data structure and algorithm, okay, so whenever you read the topic of tree data structure, let's go binary tree. Okay, so in the binary tree, guys, we learn these kind of concepts. Okay, so so when the binary search tree, a lot of words keep on coming, and we start arranging the word in the binary tree. Binary tree means we have one parent and has maximum two child. Okay, or maybe not binary tree, maybe multi-node tree also. Okay. Again, this is not DSA classes, but I'm referring those who by chance know DSA or tree, data structure, binary tree or BST trees. Oh yeah, that's what we learn this concept. But I think this without knowing the DSA also, you guys might understood what I'm trying to explain. Okay. A point here is for the computers, they does not know the English and the English sentences, neither the grammar. But they understand the tree. They know how to arrange the data one after another. They know how to create the relationships. Okay. So in the tree, you might know we use linked list to find the relationship, right? So this arrow is more like a linked list. Okay. Again, we don't have to go to linked list also to understand this concept. The main thing here is, so computer will use their computer skills. A machine, they use the machine way to understand the context of particular word in this sentence. So where they come to know chase the root word, the cat is a left side, so object noun, so subject noun. Okay, the just come before the noun, so it become a determiner, det. Okay, so that's what they given this entire meaning to you. Even though we can also find one more thing here. For example, in this example, sorry, in this document, okay, in this document, if I pick the first word, for example, the, if I ask the, can you tell me the string? Obviously, the is a string. Okay, can you tell me the the I can say dependency also? Okay, so I'm trying to ask the tell me the dependency. Okay, means we are asking them internally. We know you create a tree, you don't have to create the tree. The SPC automatically create this tree for you. For example, whenever you load into NLP, when you load into the NLP, okay, internally this sentence they convert into this tree form. In this tree form, they find one root. Tree always has one root only. One root. And we're asking, okay, with respect to this tree, wherever you have position, okay, you have someone who related to you from where you started. Okay, and the tree word is mostly from wherever you started is called parent, and this is called child. Mouse a parent, this is child. Chase a parent, mouse child. So in the tree, this is our parent-child relationship. So cat, you are a parent, your child is the, because they are coming after you. So if you ask the the this one, if you ask the, I know your the is a string, but whoever your parent is, okay, can you tell me your relationship with this? How you're related? So they say, I am the determiner of my parent. Okay, and if I ask document, can you tell me who is your parent, who your head? The same thing, head or parent. There's a cat is my head. See here? Fantastic, right? So this say my parent is the cat. And with respect to my cat, my parent, I'm putting on the front of my parent because I know the parent is cat. Cat is a noun. Anything that you put on the top of the noun, let's just with the especially, that is become determined. Again, cat is just like a specie data type. For example, if you type type keyword here is a Python code type function. So they are the specie intent tokens. If you only want to print as a string, maybe in some of the code you might have to use a string. So you can write text keyword as a property. So they become a normal string. So even though if you also find type it like a normal Python str string. Okay. So so what I'm trying to tell you guys here is whenever you use the specie and put your string in the specie will do lots of process on the top of this sentence known as linguistic analysis. And inside the linguistic analysis, they form a syntactic dependency relationship tree like this. And because of the tree, okay, specie come to know every word is a token. Okay, and because they know the relationship of this token, so they can able to identify, okay, identify because D is after, also before the cat, or because cat is a noun, it means these should be the determiner or adverb or adjective or XY. Okay, this is beautiful thing, guys. This is how we understand the language. Similarly, this is how they understand language also. One more example, let me take in the same document. This document, if I try to take the number 2, that's called chased. If I try to find out dependency of the chase to whom you are dependent on. Okay, let me check the first one first. Okay, cat. This cat, right? So ask cat to whom you depend on. So who you are means how you depend on a parent. So first of all, let me do in this way. Who is your parent? Cat. Okay. So cat say my parent is cheese. Here, this how the cat parent is cheese. And I'm asking asking to cat. You are cat, your parent is cheese. You are cat, your parent is cheese. So what kind of relationship you are having? Okay, what you are having? So can you tell me your dependency? How you dependent? Okay, so they say I am a subjective noun. See here, fantastic, right? They're not objective noun. The cat is before the chase, technically in the tree, the left side of the tree, this is called left child. So I'm saying I am the noun, but a subjective noun. Even this is entire keyword of this, the specie, you can ask specie, can you please explain me what is the meaning of this keyword and subject? So they say nominal subjective means noun, subject, noun, but in subjective way, subject. Okay. Now one more example. In this document, fourth person, we have a mouse. Okay. So ask the mouse, can you tell me your data? I'm sorry, the fourth person, can you tell me what text you have? Mouse, can you tell me who is your head? Fourth, who is your head? My head is Chase here. Mouse head is Chase. But can you please tell me how you're dependent to your head? Let's say I'm the D object. Okay. So D object is again kind of noun, but object. So again, you can specify. If you don't know, search in the Google, or you can use this explain function. Okay, tell me about what is the object. It's a direct object. Okay, you can say noun object. That's what they find for you. Okay. So point is, why is so important, guys? Because the way I started today's class, right? One single word, by knowing one single word, okay, you won't able to understand your natural language. So if you want to go for NLU, natural language understanding, okay, you need to first see where this word has been placed in your English language. And wherever they place in the English language, then you have to understand the context of this word in this particular sentence. The present tense and the past tense. But how to understand the context? By linguistic analysis. And in linguistic analysis, the linguistic analysis is like one term where they help you to understand POS, what is verb, what is noun, pronoun, past tense, present tense. Plus, under the linguistic analysis, there's a subtopic called syntactic analysis. Okay, which help us to find out the dependency and to create the dependency tree. Okay, and with this tree, everything is clear. Whichever word you place, by looking at the nearby words, if you understand that relationship, this is called dependency relationship. How? By creating this tree. And who created this tree? You don't have to create by yourself. Especially will create this tree for you. And accordingly, they find the relationship. This was a simple example, but it can be a little bit more complex example also. Let me take one more example. Okay, let's say document number 4, and I use my NLP, and I'm giving you one more word. Let's say statement I can say John reads a book. Okay, but I'm making it a little more complex in the library. Dot. Okay, see guys, just by looking at this word, so looking at this sentence, we know the English language. We should only think one thing, which is the main word here. By removing this word, this sentence has no meaning. And by looking at this entire sentence, okay, you will find there is only one word that makes the meaning of this entire sentence. Okay, it is not the book, neither the nor library. If you remove the book, John read in library, that's also make a right sentence. If you remove the library, also John read a book, that's also right sentence. If you remove the John also read a book in the library, also right sentence. Okay, which is the word? Okay, that is connect all the things. is a read actually. If you remove the read, then this sentence has no meaning. There's no grammatically right. Then it could be like a John book in a library. Okay. So it's not clear what is happening, right? It's a wrong grammar. So we just talk about this particular sentence, that internally we human being or species, I can say, they create a tree, something like this. They make the read as a root node or root. And because John in the left side, then they put John in the left side. It's called left child. Okay. And A come in the right side, but A and read has no relation. If you see here, A come before book and book is a noun. So this has become actually one part. The main part is book, so book we put here. But who give a better to the book? A. So A more like a determiner. Is a noun and A is a determiner. Okay. But who is kind of a book? Library. So library is the one who actually kind of a book. Okay. But how is the library connected? With N. If you see here also in the this one, so N is maybe, I think it can become as a preposition or maybe conjunction, depend, right? How you connect it. But I think maybe preposition it can be. Okay. Or maybe these also here. Again, this is what they do. They have created behind the scene. Okay. Or maybe before the in, I can say the actually. Because library is a noun, but the make them the kind of determiner, right? And this two become has been connected with the above one with the help of N. Okay, this can be wrong tree, but I'm just trying to give you, right? So we are not under DSA classes or other like this classes, but I'm just trying to give you the example of tree. But my point here is whenever you use a species will convert this entire sentence into the syntactic dependency relationship tree. Okay. And where through this they come to know, okay, because reads is a word, is a root, okay, and one side they have a noun, second side they have a noun, okay. So most of the verb that both the side we have a noun, or both the child in the tree is a noun, then this read is not a past. Okay, this read is a present tense. Okay, so this is document number 4, and here in the document 4, if you just search for read, and if you see the read, who is your head? Nobody. Read is the head. The head is head. The root head is always root. Or who is your what is your dependency? I am a root. That's what I am, the root of this tree. Okay. Or can you tell me something more about you? What POS you have? I am verb. Okay, can we tell more about you? Fine grain, level, tag. Is VBG. What VBG here? I don't know. So let me ask the specie what the VBG keyword explain me here. VBG is a verb, but present tense. Or person present tense. That's what, right? Okay. Why? Because the English rule. Any verb before and after we have a DAG connect with noun. Okay. That's what we write in the tree form. Then it become the sorry, the verb. Okay, so that's what they have done for us. Okay, even though if you want to, similarly, you can find many more, right? If you search the in and all the things, just keep on finding. There will be always a parent. That's called had. They also have a dependency. Okay, but if you want to create, sorry, a visual of it, graph. Okay, so then we have very interesting library or module from Specie. So the way I draw the tree graph here, similar kind of graph you can draw with the Python code also. Okay, so in the Specie, there's a way to create the graph or visual. Then there's called Displacy is a module from the Specie module. And the Displacy will give you a quick way to create a graph. So in the Displacy, there's a lot of keyword available. One of the keyword is render. Here we'll pass our document. So let me pass this document number 3. No, this one. The cat chased the mouse, right? So I'm passing the document number 3. Sorry. And Displacy will create a graph. See, a beautiful graph they create very, very quickly. And here is very clear how everything is connected. See here? Everyone start from chased. There's a verb. Nobody's pointing chase. She is the one pointing to everyone. See here? She is the one who pointing to everyone. It means she is a root. And she is the one who pointing to cat. It's noun. See here? She is the one who's pointing to cat. And also there we write here the relationship, right? She has a relationship with cat is subjective. She has a relationship with mouse is objective. But cheese has no direct relation with the D. A mouse has a relationship with the D. Yeah, mouse has a relation with the D. This is what? Determiner. Similarly, this noun, cat has a relation with the D. This is called again determiner. Okay. Similarly, let me render and create one more visual of the document number 4. Here. The read is the one nobody pointing to, which means you are the root. This side is zone. Okay, it's like pre-proposition, but maybe whatever is noun. Proper noun actually. I think proper is proper noun. Okay. Because I think it does not start with no, where it is 1 minute. With D and something like this. So it become a proper noun. Proper noun with J capital, nothing is started with D and something like this. And the book is also noun, but it's object. Okay. And this book is connected with a library. With in is a pre-proposition, and all the stuff that I explained to you. Okay, that's beautiful, right? So we can very quickly create a tree with a Displacy function to understand how these guys are connected. Okay. Other Displaces, many more options, guys, we can use in the Displacy, even though there's one document of the Displacy here. I open the document for you where it is. So you can find the Displacy document. Yeah, here is visualizers. The Specie has a Displacy function who help you to create a visuals. Okay. Create visuals the way it is. And many more different kind of visuals you can create. You can change the color, make the visual compact. You can create a visual in this way also. Okay. So there's different kind of styling of creating a visual and graph we can do from here. Right now, this visual is creating directly in the Jupyter notebook. Why? Because right now we see the help. So in the help, you can find there's a one keyword called Jupyter is enabled by default. So right now is enabled, Jupyter is true. So they create a visual directly in the Jupyter. Okay, notebook. But if you want to create a visual that can be accessed outside the Jupyter also, then what we can do, okay, in this display C, we can make the Jupyter notebook polls first of all. Now here they give you some kind of SVG document. So if you know guys how to embed the SVG in your proper front end of your web pages, you can implement, and this will create this graph in your web pages, whichever web pages you guys use. So you have to host the web page in some server. But here, Display C also given a way where you can host your web page also directly here. So they launch one local server. So instead of render, there's a function called serve function. Where Display C will host your local server like a web server. Okay. And here they does not support this keyword to Jupyter because they host a local server. That's what they host. Okay. And here they say we have launched a local server. Okay. And you can go to a local server on port number 5000. The 000 means whatever IP address you have. So in your item, I am using Windows. So I can use my Windows IP, or there's one IP address that everywhere we have is we can use here. HTTP //127 is a local IP one, and port number is 5000. So on the port number 5000, okay, they host app where they display the Display C dependency tree. Yeah, come up right. So anyone who is connected to your system, they can put your IP address from outside and can see this dependency graph. Otherwise, there's many more options you can provide here in the serve keyword. Style of the document. By default, they show you dependency always. So it's called styling. Other many more different style possible depending upon what you're looking for. Okay. So other example you can try by yourself. You can create a color, graph, compact, all the things you can put here. Okay. So guys, this topic is all about linguistic analysis. Okay. And in linguistic analysis, we have to understand the part of speech. This is called tagging. That's what we have done. Okay. Tagging part of speech, dependencies, we have to find out. And to understand the dependencies, okay, understand dependencies, we have to use syntactic analysis that will create a dependency graph. They understand the syntactic dependencies, through which we come to know how one word has a meaning in the sentence with respect to other words. Because changing the portion of the word, was a good example. We changed the entire meaning of the word. And if the word meaning changed, then the meaning of the entire sentence changed. And meaning of the entire sentence change. Okay. Then we human beings should know this. Similarly, AI model also should know this. Otherwise, if you don't know the right meaning, how they take the right decision and how they give the right answer to us, what we are looking from the AI models. Okay. This can be done by the syntactic dependency analysis. That's what SPACE is good for, to do this, right? So that's what, guys. A lot of interesting, powerful, advanced concept explained to you in today's class with a pure demonstration, okay, in multiple different way. But without the subject, okay, NLP won't be complete, right? Like this, there many more interesting things we're gonna see in the future classes, but there's also one very very important topic I cover with a lot of use cases and a lot of practical examples are given to you with our codes also. So that's all from my side. Any query if you have, you guys can ask me, or otherwise we'll see you in the next class, guys. Any query anyone has, you guys can ask me. Yes, everything behind the scene, guys, is created with the token IDs. For us, they only give you the names, okay, but behind everything, SPACE understand every word as a token ID. Okay, for example, here they have given a token called read. So here word is like a token. But internally, SPACE give every token a ID is called token ID. So all this mapping or calculation behind the scene, what SPACE doing, they're doing with the help of token ID. Okay. I think Abhishek, what you're looking for has been done from my side already. Create a graph in a visual form. This is the display. Missing you, sir. Same here, Devans. Same, missing you, everyone. So that's all, guys. I believe very, very interesting topic. But NLP, I think you now understood and make the machine understand your natural language is not small thing, right? A lot of concepts you have to connect together to understand the natural language, and many more things gonna come up in the upcoming classes. Paresh, you don't have to pass multiple function is same, okay? But in the function, when you pass the multiple arguments, that time you can write data. Let me write the code for you very quickly. So in the apply function, guys, what I explained in my last class is, so let's say your data set. Here you can give a list of argument, for example, name, comma, mobile number, comma, maybe city. So these three arguments, if you want to pass to the apply function, just write apply. Same, your function name, let's say my actual function. Okay, then all these three will pass to this function. Now in this function, okay, because you're passing three, variable name will be only x. You use only one variable. But in one variable, if you're passing three, then this variable become a tuple. Then you can say x 0% name, x first person mobile number, x second person would be city. So name will pass to 0%, mobile will pass to first person, city will pass to second person. So in the apply function, you're going to call the function without the argument only, but all these three things will go to this function as a single variable only as a tuple, where everyone has their own 0, 1, 2, 3%. Okay, so this is how you can pass in the apply function. Okay, so that's all, guys. We'll see in the next class. Our code has also been, I think, provided by my team, Abhishek, right? If it's not given to you in your Google Drive, let us know. Okay, otherwise I believe all the screenshot and the code has been given by my team in your Google Drive. It is not coming, please let us know. We'll provide you the code also. So that's all, guys. See you in the next class with more detail or more use cases of the NLP. We'll see in the tomorrow class. Get good, guys. See you. Take care. Good night.